Today we are going to work on factoring polynomials. This is part 2. We'll be working a lot with sum and difference of cubes with the greatest common factor, and then we'll get into factor by grouping. So first, here's a review of difference of cubes. We have an equation for the difference of cubes. We have an equation for the sum of cubes. Notice this one will have a plus sign, minus sign, and you can take the cube root of both of these. Now, nothing that changes here is the signs. If this is a minus, it starts with the minus, and these are opposite. If this is a plus, it starts with the plus, and these are opposites, and you always end with the positive. Let's go ahead and do example number 1 as a review. So we see x cubed, and so we're going to check if we can take the cubed root of both of these. So we're going to go ahead and check. Can I take the cube root of 343x cubed? And the answer is yes, I can. And so my a value is going to be 7x. Then I try taking my cube root of 27, and my cube root of 27 is 3. So there is my a and b value, okay? Now I'm going to go ahead and plug those into the equation for the difference of cubes. We have 7x minus 3. And on the second one here, I'm always going to plug in parentheses because I have to make sure I square it if I have a number. So every time I plug in a number, I'm going to put parentheses. So I'm going to have 7x squared plus 7x times 3 plus 3 squared. Okay? Now our goal is going to be to simplify these, which means let's go ahead and get rid of the double parentheses. Right here, the biggest mistake is students putting 7x squared, but it's not. It's going to be 49x squared because I have to square the 7. Okay? We're going to multiply the two numbers in the middle and get 21x, and then 3 squared is 9. Okay, next we're going to work on example number 2 together. So something I didn't talk about here because I looked at these and I was like, okay, nothing's going to go into them. But when I get down to this number, I notice that they're both even. So already in my head, I know that I'm going to have to take out a greatest common factor. So then I start thinking, what number is the greatest number that goes into 64 and 216? So I notice that 2, 4, and 8 go into this plus some other numbers, and I check this one out. I'm going to have to factor out an 8. So guys, if you don't choose the right number to factor out first, you'll just notice that you have two evens again, and you'll have to continue factoring out by a larger number. So when I factor out, I get 8x cubed plus 27. So now I look inside the parentheses, and this 8 is just going to be at the beginning of my answer. It's not going to change anything. Can I take the cubed root of both of those numbers? And I can. So I'm going to take the cubed root. I'm going to take the cubed root. So my a value is going to be 2x. My b value is going to be 3. So when I work this out, I still have the 8 on the outside. But now I have 2x plus 3. And I have 2x squared. Make sure to square all of the 2x. And then I have 2x times 3. And last but not least, I have 3 squared. Go ahead and get rid of the double parentheses. So when I square the 2, I get 4x squared minus 6x plus 9. So always check if you have a GCF first. So let's come over here to practice number 1 and notice that they're both even. So you're going to try to find out what's the biggest number that goes into both of these first. So try practice number 1 on your own. Okay, check how you did on it. So here was the tough part. What number was the greatest number to factor out of here? Now, luckily it was 8. 8 was not a huge number. So 2, 4, or 8, I checked what was the biggest one that would go into it. And 512 did divide by 8. So I factored out an 8 first. Let's go ahead and look at this one. We have 729 and we have 125. Does it have a greatest common factor? No, it does not. So go ahead and do your sum of cubes on practice number 2. Okay, check how you guys did. There was no greatest common factor. And guys, what's a good way to see if I have a greatest common factor? Well, right here, the biggest mistake is you can take the square root of both of these. But if you just took the square root of both of these, the cube root of 512 would be 8. And so if you're taking the cubed root and you have an 8 and you have a 2, they're both even numbers, and so I knew I could factor them further, okay? So always check for GCF first. Now going along with that, here's still some more GCF with practicing of them. These are some smaller numbers, so maybe a little bit easier. So here's example 3. What's the greatest common factor of 16 and 16? Well, the answer is 16. So I can pull out a 16 in front, and I'm left with x cubed minus 1. So then now can I take the cubed root of both of these? I can. And so my a value is x, and my b value is 1. So now, just like the previous ones, I'm going to plug those into the equation. Now, the one thing different, that 16 is in the front. So it's just more practice and enforcing our skills. So x squared, and this is a plus x times 1, and then plus 1 squared. Okay, so getting rid of the double parentheses, we still have that 16, so put the greatest common factor in front, and now we can get rid of the double parentheses. Okay. So we'll go and do example number 4 as well. So we did example 3, we'll do example 4, and you guys will practice these ones on your own. For this one, I look at these numbers, and I actually see that a 3 goes into both of them, and an x goes into both of them. So I'm actually going to factor out a 3x, and I'm going to put that 3x in front. And when I divide by 3x, I'm left with x cubed plus 8. Can I factor any further? So you always check if you can factor any further. Can I take the cubed root of both of these? If the answer is yes, I have to keep on going. So what's the cubed root of x cubed, and what's the cubed root of 8? That means my a value is x and my b value is 2. Don't forget that you factored out a 3x, which will go in front of it. So the sum of cubes is x plus 2, and then it's going to be x squared minus x times 2 plus 2 squared. Okay, so let's get rid of the double parentheses. 3x, x plus 2, x squared minus 2x plus 4. So go ahead and try practice number 3 and practice number 4 on your own. Okay. Make sure you take out the greatest common factor first. This one had a 2, so when I took out the 2, I could still take the cubed root, so I continued this problem. On this one, my greatest common factor was 2x, so then my a was x, my b was 5, and I plugged them into the equation. Okay. So the last thing we're going to cover today is factor by grouping. So factor by grouping is where you put the first 2 terms together, you put the last 2 terms together, and you check if you can take out a factor, and then you see if they have common factors within them. So what I mean by that, if that makes sense, you're going to put the first 2 together, you're going to put the last 2 together, you're going to make sure that you have a plus sign in between. Since you're not multiplying them, you're adding them. In the first parentheses, I look at the numbers and I have to look at the variables and what can I factor out. Well, they both have an x squared in common, so I'm going to take out an x squared. I'm going to factor it out. On the second one, I look, and I don't see a number, but I do see a -1, so I am going to factor out the -1 and put it in front. So I'm going to put x squared in front, and when I divide by x squared, I get x plus 4. Here, when I divide by -1, and I divide by -1, I also get x plus 4. So if they have a common term in the parentheses, that is one of your factors, and your coefficients is the other factor. So x squared minus 1 and x plus 4. Now we always have to check if we can factor any further. This goes back to part 1. A difference of squares. So we didn't talk about difference of squares today, but we talked about it in the previous video. If I have a square or something that I can take the square root of, this right here has 2 factors. This factors to a sum and a difference. So if you can take the square root of both of them, Okay, it's one sum, one difference, and we're still going to bring down the x plus 4. Okay, let's see if the same thing happens in example number 6. I'm going to group the first two, I'm going to group the second two, and I'm going to make sure there's a plus sign in the middle, and there is. In the first parentheses, I can factor out x squared. So I'm going to factor it out by dividing and writing it in front. And I'm left with x minus 2. The second parentheses I can factor out as 16. So I'm going to factor out as 16, and when I divide by 16, I get x minus 2. Okay, so if they have a common term, I'm going to put my coefficients together. Can I factor that any further? Is this a difference of squares? Well, I can take the square root of both of them, but there is not a minus sign. Therefore, this cannot be factored any further. So you always look at your factors and you see, can I go any further? So go ahead and try practice number 5 on your own. Okay, check how you did on this. So this looks very similar to the one above it, because when I factored it out, I had x squared minus 9. This is a difference of squares because I can take the square root of both of them. So I take the square root and did 1 plus, 1 minus, and brought down the x minus 1. Okay, go ahead and try practice number 6. Okay, so check how you did. Now be careful here. I could not go any further because, yes, I could take the square root of them, but the problem is this is not a minus sign. So this is not a difference of squares, and this is the most factored I can go. Hopefully this video helped you with sum and difference of cubes and introduced you to factor by grouping.